So welcome back. So today we will see exact differential equation. So for example, this is a differential equation m dx plus n dy equal to 0. So for this differential equation to being exact differential equation, the condition is dou m by dou y is equal to dou n by dou x. So you need knowledge of partial derivative as well as total derivative to understand this. And the solution of this type of differential equation of form m dx plus n dy is this, where you first integrate the m function assuming y as constant, and then integrate n terms without x with respect to dy, and then add a constant c equal to 0. So we will see how we will find the proof of this, because proof is also important, otherwise you won't understand the basic behind it. So these things we are going to use in this video. So total derivative of a function f x y is df is equal to dou f by dou x into dx plus dou f by dou y into dy. So this is partial derivative of f with respect to x, and this is partial derivative of f with respect to y. So what does partial derivative of x and y mean? So this is the basic formula. So here you can see that in terms, when we find partial derivative with respect to x, we only change x and y is constant. Okay, and when we find partial derivative with respect to y, we only change y, see, and x is constant over here. So for example, if you see that if you want to find the partial derivative of m with respect to x, then you have to consider y as constant. So here y, when you will differentiate it, you will get 2x, and here you will get 0. And similarly, if you differentiate this m function with respect to y, you will have to consider x as constant. So now here you will get 0 for this and 2y. So I hope that you have understand how to find the partial derivative, and like you can revise in detail, but this was a brief introduction. So now we want to find how we have come to this formula, this final solution. So we will understand this proof via illustration. So just take an example of this differential equation. So here this is a form of m dx plus n dy equal to 0, where m is a function of xy and similarly n is also a function of xy. So if you see, what we want to do, so actually we want to finally come up with a, like, we want this to be dou f by dou x and this to be dou f by dou y, and we will assume this. Why? Because what is the benefit of this? We will get dou f by dou x into dx plus dou f by dou y into dy equal to 0, and by the formula of total derivative we have seen that it will be equal to dou f dfx fxy equal to 0. And we know that if something's differentiation is 0, means it is a constant, fxy equal to constant. So we get our final, like, parent equation from this differential equation. So this is our solution. So our only task is to find fxy, and we will see how we will find that fxy. So I hope that you understand how we are going to approach this using this total derivative. So, and also why we are checking the condition of dou m by dou y is equal to dou n by dou x. So you can understand this because if you differentiate this is m. We have already seen this is m and this is n. Now when you find dou m by dou y, so you differentiate it with respect to y, and when you find dou n by dou x, so you differentiate it with respect to x. So it is equal. You can see that, because you will get from here, one side you will get dou square f by dou y into dou x, and one side you will get dou square f by dou x dou y, and we know that this is equal. So that's why we want to check the exactness of this function. So that's why we check this condition of this exact differential equation by this. And now we are just have to find the function fxy. So we assumed this as dou f by dou x and this as dou f by dou y. So what we will do is we will first solve this. So you get dou f by dou x is equal to y plus x minus 2. So what we will do, we will integrate it with respect to x. We will get f as y plus x minus 2 integration with dx. But remember, this is a partial derivative, so this is the x world. So in x world, when you will integrate, you will get a constant, and y is a constant in this x world. So here you will get y into x plus x square by 2 minus 2x plus, so here you have to be careful, here one hy will come because a constant is there. Just remember, y is a constant, so if you differentiate this, so you will get this cancelled out. So that's why we have to put a constant also of hy. So now what we have to do in our step 2, so since we have differentiated with respect to like partial differentiation with respect to x, now we will partial differentiate with respect to y. We will interchange, we will do other way. So dou f by dou y we will find of this. Suppose this is equation 1, so we are finding the dou f by dou y of equation 1. So we get f, we know already this is our f. So when you do partial differentiation of this function with respect to y, so x is our constant, so x will be as it is, and when you will do it, so y is equal to 1, then again this one you will get 0, this again you will get 0, and here h of y, if you differentiate with respect to y, you will get h dash y. Okay, so now we have assumed earlier that this is equal to dou f by dou y, so just put it here, x minus y plus 4, x minus y plus 4 is equal to x plus h dash y. So here you can see that your x will get cancelled and you get h dash y as minus y plus 4. Now integrate it with respect to y, minus y plus 4 dy. When you integrate it, you will get minus y square by 2 plus 4y plus a constant. Okay, so now just put this in our equation 1 and you will get the solution. So when you put this in our equation 1, here our equation 1 is yx plus x square by 2, yx plus x square by 2 minus 2x minus y square by 2 plus 4y plus c equal to 0. So this is our final equation and this is our solution. So now we have to understand how we got this formula. So this formula mx y dx, where we first integrate assuming y as constant, then second we saw that n terms not containing x. So if you carefully see here also, this term we got by integrating m with respect to x assuming y as constant. You can see here. So what we did earlier, here we did integration with respect to x assuming y as constant, and the second term, this one, we got when we integrated without any x term. See, when n is not having any x term and we are integrating with respect to y, then we are getting this. So I hope that you have understand this, that m dx where y is constant plus n terms without x, and you have to integrate with respect to dy plus c equal to 0. So that's our final formula of how we will find the solution of the exact differential equation. So I hope that you have understand this derivation. So you can rewatch this video if you are finding any confusions. So let's try to solve this problem. So as always, first you can pause the video and you can try by yourself, then you can see the solution. So okay, let's start. So if you see here, this is m xy and this is n xy. So first we will check for the condition of exactness. So we have to find dou m by dou y. So remember, when you are finding of f for m, you have to partial differentiate with respect to y. You have to partial differentiate with respect to y. dou m by dou y you have to find. So and on the other hand you have to find dou n by dou x. So when you find dou m by dou y, this will become constant. X is a constant, so here you will get 1 plus 1 by x, and here you will get minus sine y. Now let's differentiate n term with respect to x, partial differentiation with respect to x. So here you will get 1 plus 1 by x minus sine y. So you can see that both are equal, means our differential equation is exact differential equation. So now directly apply the formula that we have studied. So here we will consider y as constant and we will integrate the m with respect to dx. So you will get y 1 plus x plus cos y, we have to integrate with respect to dx, plus now we have to take n terms that are independent of x. There is no x there, but if you see here you will get x here also, and here also, means you don't have any such term. So here you will get 0 dy plus c equal to 0. So now further if you integrate this, so you can see this will become y x plus y ln x plus cos y into x plus c equal to 0. So this is your final solution of our question.